What's up, Logic fans? Welcome to another video. We're hitting section 4.12 of the text today, our 12th section on quantificational symbolization. We're going to introduce the identity symbol today, the symbol you're all familiar with, okay? And we're going to find that once we introduce the identity symbol, our expressive power increases a lot. Our typical procedure here follows what we've done in the rest of chapter 4. So in 4.12 here, we're going to cover the mechanics of identity symbol, how to form sentences properly using the identity symbol in our system. And then once we've got that down, we'll move on to 4.13 and talk about the meaning of identity statements for us. All right, let's rock. Okay, so now that we're approaching the end of chapter 4 and all this new symbolic devices, I want to review briefly and make sure you're keeping in mind the big picture of what we're up to. So if you recall, we found that propositional logic was inadequate. That means that there are certain arguments which intuitively are valid, but which we cannot demonstrate to be valid using only propositional symbolic devices. So we had to go on this journey of a new way of representing sentences, a way that revealed more of their logical structure than propositional symbolization allowed for, okay? And we've basically got that in place now. So once we're done with that, we will then start up with Chapter 5 looking at quantificational semantics, and then ultimately Chapter 6 quantificational syntax and how inference works with all of this new devices. So, what are some of the devices that we've introduced in Chapter 4? We've got our individual variables, we've got our individual constants, we've got all the logical connectives, we've got these bracketing devices, okay, the parentheses, we've got our universal quantifiers, we've got our existential quantifiers, you've got your property constants, you've got your relational constants, and the last piece of technical machinery we require is the identity symbol, okay? So that's the last one. So we're going to hit the mechanics of it and how to form sentences using this new symbol presently, and then we'll talk about in 4.13 the meaning of the sentences, okay? So that's where we're at, where we're going, and why we've been doing what we've been doing. Okay, our new symbolic device then is the identity symbol that you're used to seeing from arithmetic, so things like 2 is identical with 2, 2 is identical with x, whatever, okay? It's the identity symbol. And basically you're going to be forming sentences that look, like this, where the idea is that A is identical with B. Now, we can also say that A is not identical with B, and typically the way we're going to do that is just by appending the identity statement with the negation, like this, okay? Now, oftentimes we're going to write it slightly differently, so instead of writing it this way here, we can say that A is not identical with B. Sometimes what we call numerical diversity, A is numerically distinct from B, by using this symbol. Let's see, I can pull it up here. Yeah, so this symbol, okay, so these two ways of writing things are equivalent for us. Now, this is technically a new symbol, and so this is officially going to be known as a shorthand, okay? Officially, this is our correct way of expressing that A is not identical with B. Would look like this, but oftentimes we're just going to write it this way because it's easier to look at. But I don't want to introduce a second new symbolic device. We only need this one new device, and then we can just use not to say this kind of thing. But conventionally, we're going to write it this way a lot of the time. Okay, so the identity symbol is the new device. Now, how does the identity symbol get used in conjunction with all of our other symbolic apparatus? Well, officially, we're only adding one new quantificational sentence rule, which is nice. So here it is. So officially, we're going to add this rule here to our QS rules, and we're going to drop it in the third place. So QS1 still says that any propositional constant with an individual constant appended to it is a sentence all by itself, okay? QS2 still says the same thing for relations, so RAA, RAB is a quantificational sentence, okay? And now we've got QS3, which is the identity sentence, and then after that, QS4 is negation, QS5 is and, QS6 is or, QS7 is if-then, QS8 is tribar, QS9 is universal quantifier, QS10 is existential quantifier, and then QS11 is basically nothing else is a sentence unless it can be shown to be so by implementation of these rules. Okay, so those are all laid out cleanly in the textbook, but this is our new one. So the identity symbol, that's this guy, appended with either two individual constant tokens of the same type, that would be this. Okay, that's a sentence. Two individual constant tokens of the same type. Okay, these are all sentences. Okay, according to QS3. Or two individual constants of different types and surrounded in parentheses. So let's see here. Two individual constants of different types. So this is a sentence. That's different types. All right, different types. This is a sentence. Right, that's a sentence. Okay, all of that, all of these are sentences, but technically they should be surrounded in parentheses as QS3 technically requires, but often, as is our practice for convention, we will sort of omit these for readability. Okay? All right, let's try some examples together. So, for example, how would you show that this expression is in fact a quantificational sentence? Pause now. Okay, so it's pretty straightforward, right? But you would just write it like this. You would just write A is identical with A, and then you would put, QS3, okay? And that's all it is. Technically, this should be surrounded in parentheses, but we're omitting that for readability. Let's try another one. How would you show that this is a quantificational sentence, this expression? Pause now. Okay, nothing too bad, right? But it's just going to be like that. Okay, so remember, it allows you to do it either with two of the same type or two of different type. Okay, so pretty straightforward. Let's suppose we did it slightly differently. Let's do one like this, except let's do non-identity. So let's do it like that. Numerical diversity. Show that this expression is a quantificational sentence. Okay, this one's going to behave a little bit differently. Okay, so we're going to start off with this, QS3. That's how we get the identity symbol on board, and it's the only way we can get the identity symbol on board. After that, what we're going to do is we're going to write this. Now, what rule was that? Well, that technically is going to be QS4 applied to line 1, and as a convention, I'm allowing you to write this just this way. Okay? So that's just a convention for us, all right? But technically, it's applying the negation to it, so it's QS4. Okay, that's the point there. Let's try another one. Show that this is a quantificational sentence. This expression right here. Pause now. Okay, so first of all, we're going to do this, and that's going to be QS1. All right. And then, of course, we're going to do A is identical with B, which is QS3, our new rule. And then, of course, we're going to combine them, and so that's going to be QS5. So we're going to do FA and, actually I have it here, so we'll do let's do QS5 on lines 1 and 2, okay? And that's exactly how it's going to work. All right, one more for these sort of simpler ones. How about a sentence or an expression like, let's do this, where you have to use a relation with it. How would you show that this expression is, in fact, a quantificational sentence? Pause now. Okay, so let's get its different parts going. We'll do RBJ. That's going to be QS2, all right? And then, of course, we're going to get J is identical with B, all right? That's going to be QS3. We're going to negate that, and so we'll get this expression right here by QS4, all right? So that's going to be QS4 on line 2, okay? And then, of course, what we want to do is we want to combine them using if-then. And so this is going to be QS, let's see, 4 is negation, so 5 is and, 6 is or, and 7 is going to be if-then. So that's going to be QS7 on lines 1 and 3, and that's QED. Okay, so this is how we form expressions using the identity symbol. Let's keep looking at more and more advanced cases. Try a case with a quantifier. Let's see how you do with that. Try this case. Pause now. So this is an interesting case, all right. Okay, so let's go ahead and try this together. You can do this either with A is identical with A, or A is identical with B, or A is identical with C, whatever you want. We'll do it this way. So this will be QS3, okay? And then, of course, what we want to do is we want to follow the rule for introducing a quantifier, okay? And, you know, that rule basically says you take the thing here, right, in this line, and you surround the whole thing in parentheses, and you append a quantifier in a variable type that does not occur in that line. So the X does not occur there, so we're good to go. And replace at least one of the tokens here with that new variable. So in this case, we're going to choose this one. We could do both for A if we wanted. If this was A and this was B, you could not do both. You could only do one. Okay, so it basically is behaving the same way as with relations. And it's designed this way to make it easier for you to digest and pick up quickly. So yeah, this is going to be QS. What's our new existential quantifier rule? Well, it's the second to last one, so it's QS10. Okay, the last one's QS11. So it's QS10 applied to line 1, and that's it. Okay, so this expression is a quantificational sentence because it can be built up following our rules, and we have this new rule allowing us to get the identity symbol involved. Okay, just to make sure we're all catching all the nuances here, try this one. Okay, so try this one. So notice I've got the variable in this position as opposed to that position. Pause now. Okay, so the way we might try this is maybe we would introduce C instead. That would be QS3. And then basically you would be taking this whole thing, putting it in parentheses, surrounding it with a quantifier. It wants it in terms of Y, which is fine because Y does not occur up here. And then it wants the Y in this position, which you're allowed to do. You could do both because you have it in terms of the same variable, or the same individual constant, but it just wants the 1. So that's how we would do it there. Okay, exact same thing, no problem. Our rules cover this really, really nicely. Let's look at another. Let's try one with a quantifier and negations, non-identity, numerical diversity. So let's try, let's try something like this. Go ahead and pause and give this one a shot. Okay, so I might start off with, B is identical with B. And the key thing here is that this is QS3. Okay, this is our new rule. Introduces the identity symbol. We're going to go ahead and negate that, and that's going to give us this expression here, but with the B like this, and that of course is QS4 applied to line 1. So we've got the negation, and again, technically it should be negation and then this whole thing in parentheses, but this is a convention we're allowing, okay? And then what we're going to do is we're going to tack on the quantifier onto that particular expression. So I'll show it step by step. So we're going to take this whole thing, surround it in parentheses. This is just QS11, all right? This is the rule QS11, and we're going to have the quantifier in terms of Z, which does not occur in this expression, so we're okay to put it on there. We've got the Z on there, okay, and we've got to replace at least one of these with the Z, and because it wants it on this one, we'll do it on that one, and that is QS, what is that? It's going to be QS10 on 2, okay? So this is, in fact, a quantificational sentence for us. Okay, let's go into the next video, and we'll just keep working through examples of what kinds of constructions are possible with our new identity symbol and which are not. So look for 4.12b.